Today we're going to learn a new notation for antiderivatives, and this notation is going to be something that we're going to use quite a bit going forward, but it really is just asking us nothing other than an antiderivative. So to get started, what we're going to do is we're going to write this like crazy notation. So we're going to write this like script ds f of x dx, and we're going to say that's equal to the antiderivative of little f of x. And so that's all this is saying here. And the reason we see that is that the derivative of capital F is that thing, which means we're looking for the antiderivative. So if I write like something like this, all that means is find the most general antiderivative of x squared. So in that case, that would be 1/3 x cubed plus c. Note, since these are asking for the most general antiderivative, we're always going to have a plus c in our answer. These expressions are called indefinite integrals. And so the way that we read something like this, we read that as the integral of x squared dx. Notice it's important to put the dx there. It's reminding us what variable we're working with. You can sort of think of this as like parentheses. If I have an open parentheses, I need to close my parenthesis. With an integral sign, the thing that's like closing the parenthesis is the dx. The integral and the dx belong together. That could be a dt or a du or a dy if our variables are t or u or y. This is not quite as, you won't quite understand why we need this in this class, but if you get to a Calc 3 multivariable calculus class, you're going to have lots of variables floating around. And so you might have a dx, dy, dz at the end of an integral. So it's really important in that case. So let's go ahead and do some examples. So remember, all this is asking is what's the most general antiderivative. So I'm going to rewrite this one. This is 6x to the negative 2 minus 1 over x dx. The antiderivative of 6x to the negative 2, I add 1 to the exponent, so I get negative 1. I divide by negative 1, so that'll just give me negative 6. 1 over x, remember that's a special case. That's just ln of the absolute value of x. And don't forget we need the plus c here because we're looking for the most general antiderivative. Okay, you should try these on your own before you watch me do these. But this next one, this one's one we have to remember. The antiderivative of 1 over x squared plus 2, what function gives us that derivative? That would be arctangent of x. That might be one that you kind of forgot, but don't forget it. This one we need to simplify first. So this is x to the 1/2. So I'm going to get 1/6. When I do, well, I'll go ahead and write out all the gory details. This is x to the 1/3. Now I can subtract these exponents in each case. So when I do that, I'm going to get 1/6 x to the 3/2 minus 1/6 x to the negative 1/6. And so now when I differentiate, if I add 1 to this exponent, I get 5/2. I multiply by 2/5, and I still have that 1/6 up front. 1/6, when I add 1 to that exponent, I get 5/6. I multiply by the reciprocal, so I multiply by 6/5, and I add c. You can certainly simplify those coefficients, but I'm being lazy right now, so I'm not going to. Okay, so this one is easier after that last one. This one's just going to give me 1/3 t cubed plus c. This one is going to give me 4e to the z plus 16z minus 1/6. We're going to treat this as 1/6 times 1 over z. So this is 1/6 ln absolute value of z plus c. This one looks like I'm going to need to simplify things first. So this will give me the integral of 7 over cosine squared x. I'm going to have cosine squared over cosine squared, so that's going to give me -6. I don't know the antiderivative of this right now, but remember cosine, 1 over cosine is secant, so that's just 7 secant squared x minus 6 dx. Just remember, what's the function whose derivative is secant squared? That's tangent, so this will give me 6 tangent of x minus 6x plus c. One thing you might have noticed as we've been going through these examples is that if I have something like 7x squared dx, I can really treat that. I can kind of pull that 7 out, or I can pull that 7 out. And so I'm going to get 7 times the antiderivative of x cubed. So that's what this first property is telling us. I can just pull constants out. The second property is telling me if I have two functions added together. So if I have like x cubed plus e to the x, That's the same thing as anti-differentiating x cubed and then anti-differentiating e to the x. And we've really been using those properties, but it's nice to have those written down. We'll do tons of examples in class.